So this is going to be our fourth meeting of the year, and this time it's going to be a topic that I believe everyone is going to end up using at some point or another in their career. So you guys probably already know, we're going to be talking about Git. So Git is what we call a version control system. So a version control system, you can probably tell by the name, but in general, you use it to track file history. You use it to track the history of your files, your folders, and you can also use version control systems to collaborate with other people. So normally, the traditional form of file control that most students use, they just do it locally, like with their files, they create copies to back them up, or they just create separate folders for separate branches of some kind of project. But Git lets us do all of this in a much more effective and efficient manner. So conventionally, many companies use Git. That's why I say you will eventually end up using Git at one point in your career. It's just too good. The amount of usefulness that Git can give you cannot be stated in words. And when you actually start using Git, you'll know what I mean. But when you use version control systems, basically you can find out why certain changes were made in code, especially code you've written a long time ago. You can work on different branches of a program and collaborate with other programmers. So to understand all this, we have to understand how Git works. So in Git, we have something called commits. So commits are basically the core part of Git. So commits you can think of as like a snapshot of your files. So if you had like some sort of files in a directory, when you commit something, you basically take a snapshot of those files or those folders in that directory. So the way Git's data is modeled, it's important that we understand this because every command that you use in Git will manipulate this data model in some way. So when you commit things in Git, you can model it like this. If you make some initial commit, you can think of it as like a node on a graph, right? And then when you make another commit, then you will make another node, but that node will point to the node before it. And we will call this node then the parent node, the very first node that you made. So this is what they call a directed acyclic graph, a DAG, which is a mathy term, but essentially it's just meaning that every time you make one of these new nodes, it's going to point to the parent before it. Somewhat like a linked list, you can think of it like that. But even a linked list is actually a really good way to model it because the way everything works in Git, you essentially have references. You don't actually have objects directly, but rather you point to those objects. So Git does have objects. They have three kinds of objects actually. They have what are called trees, they have blobs, and they have, of course, commits. And these are going to be all the objects. These are types of objects, and you are also going to have references. So this is pretty much the fundamental basis behind Git, objects and references. So in Git, you can't really change objects, but you can create new references and you can update references. So you can consider objects immutable. Objects cannot change, but references can. So in Git, typically trees is almost synonymous with folders. You can consider it as like a folder. So folders, you can model them. If you guys are familiar with maps. So maps in programming, you can map something like a string to another object. So a tree, what they do is they map a string to another tree or a blob. So what I mean by that is the way Git works is they have reference numbers essentially. So you might have something like FCD, 9, 8, just some random number, and this is going to be basically like the tree itself. You're mapping this to the tree, and you're gonna have a string that maps to it. So typically you will have the string, and then this is going to map to the tree or the blob. So that's how Git really works. And blobs are essentially the data itself. You can model them as an array of bytes, really. So blob equals array of bytes. If you know what an array is, it's just going to be a collection of some type of object. And then last we have commits. So commits are a little bit more complex, but you can think of them as like a class, and they're going to have a few data types. They're going to have a parent, which is going to be an array of other commits, right? So like if we go back to this, we can see that each commit will have a reference to the commit behind it. And it can also, you can have branches from each commit. So you can have something like this. So that is why we have an array of commits. And another thing it's going to have an author, it's going to have a message, and it's going to have a snapshot. So the author is going to be basically the username of your computer. It's going to identify your commits with your name. So it's just going to have some name, and then a message. Each comment you make, you have to give it a message. So it could just be some random message, like you just have default as a string. And then you're going to have a snapshot, which is always going to be a tree. So a tree we have here, a tree is just going to be a mapping of a string like this, to another tree or a blob. That is a reference. So we're talking about comments here, but the way comments work is a little bit strange. So in Git, you have 3 sections. You have what's called the working tree, you have the staging area, and then you will have a Git directory. So the working tree, underneath this, you're basically going to be making changes to a file, and while you're making changes to a file, it's going to be here in this working tree. So if you just like add some line of code, or you add a file or something like that, so like let's say add file, it's going to stay here. But to actually track this file, it's not going to be tracked unless you move it into the staging area. Once you move it into the staging area, it's going to hover in that staging area, right? So then you're going to have this file floating around the staging area. But once you have this file there, you've tracked the file, but you haven't actually made a comment with it yet. So when you make a comment, it actually goes into the Git directory, and then it becomes completely tracked. So eventually the file will actually become a commit once you comment it. And then once it's commented, it's going to have this sort of metadata associated with it that allows it to work with other Git tracked files. So generally you're going to have these 3 sections, and you're going to be moving files from this section to this section. And that's pretty much like a basic Git workflow. And to go with these, Git has 3 states that a file can be in. Files can be modified, and if they're modified, they're going to be in the working tree. And they can be staged, which means they're going to be in the staging area. And lastly, they can be committed. And of course, when files are committed, you're going to be in the actual Git directory. That means you've done the tracking, you've tracked the file essentially, and you've put it in the Git directory. So you can think of a basic Git workflow as you modify files, they go into the working tree and they become modified. 2, you can stage your changes that you've made to the file, and it's going to go there. And then lastly, you're going to comment. And comment is the final step, and that's when the file becomes commented. So let's actually go ahead and take a look at Git and how this works. So what I'm going to do here is going to make some sample directory, and once I have this, cd into it, and I'm going to initialize this directory. So let's go over some commands real quick, just a few. So when you type git init in your command line, you're initializing a repository in your current directory. So this is basically the most basic Git command. This is what you actually start your Git directory with. So you can think of it as like the first step to version controlling your project with Git. So once we have that, let's say I want to make some sort of file. So I'm just going to say some sample text. I'm going to put it into a example.txt file. ls, you can see that there. So I'm going to type in a command called git status. So when I type git status, it's basically going to show me the information regarding the current branch I'm in. I'll explain what branches are later. And it's going to explain the file states. So we talked about the file states. They can be modified, staged, or committed. So right now, we've modified the file, right? So the file is here, but we haven't actually staged it yet. And it's going to say untracked if you haven't actually started tracking the file by putting it in the staging area. And the way we actually track it and put it in the staging area, we say git add and then the name of the file. So once I've done that, you can see new file example.txt is going to be green. It's going to see changes to be commented. This means you're tracking your files, but this doesn't necessarily mean that it's actually going to go into the Git directory. So this is useful in the sense that you can make changes, but you don't actually have to commit yourself to them. When you really do want to commit these changes, though, of course, you can actually finally go ahead and git commit, the final step. And I'm going to give it this option here, -m. So the thing is, when you do git commit, it's going to give you like this, it's going to open up a text editor, and then you can give it a message for your comment, but I'm not going to do that. I'm going to go ahead and do -m, which is going to let me do shorthand. It's going to not put me in the text editor. I'm just going to say initial comment, just some random message, but ideally you want to make it a nice and descriptive message because you will be referring to these later. So once I've gone ahead and done this, I've effectively gone ahead and actually gone through all three of these stages. First, I have this file, I add the file. Well, actually I don't add the file here, but I make the file, but it hasn't been tracked yet. At that point, the first step. And then I'm going to move it in the staging area by doing git add. So let's say git add. And then finally, I move it from the staging area into the actual Git directory by doing git commit. So this is the most basic workflow of Git and probably the main use of Git, but there are some features that make Git more powerful than other version control systems, and we'll go into that in a bit as well. But I'm going to show you guys that this can actually be modeled. If you do git log, it's going to show you the commits you've made. So if you type git log, it's going to show you the commit and it's going to show you the string associated with it. So you have like this long like hexadecimal string, and you have this thing called head and master. So what head means, head basically just means the branch that you are on, the branch you are focusing on. And master is just conventionally refers to like the main branch of your development, like the main project really. So the most recently updated version, the one that you want other people to work on or you want to work on. It's just a conventional name. But head is important. Head is the branch that you are currently working on. So I mentioned commits and also mentioned branches. So we're going to actually look into what branches are now. So we have git log. So what I'm going to do is I'm going to go ahead and make a change to the file that we have in there to example.txt. So I'm going to add a second line and append it to example.txt. And if I do cat example.txt, you can see it's been changed. So if I do git status now, I'm going to say modified example.txt. Okay, I want to comment that change. I'm going to just go ahead and say add second line. Oh, whoops, I had to add the file first, my bad. And now I've gone ahead and commented that. So if I do git log now, I have two comments. And let me blow you guys' minds here. So here's what you can do with Git that really sets it apart. You can actually go to the previous comment. So what I'm going to do is notice a string right here. So I can actually type out like the first few letters of it. And I can actually go into that branch, that comment. I can go to that previous comment in my file history. And it's basically like I'm turning back time. So if I do ls, you can say example.txt. I can do cat example.txt. I'm going to say sample text. See, this is when I first made my initial comment. If I do git log, you'll also see that my head is actually pointing to the first comment, and it also doesn't even know about the other comment. So I'm actually going to go to the newer comment now, though. I'm going to do git checkout c927. And now if I do git log, you'll see that the head is now on the newest comment. And if I go ahead and read example.txt, it's going to have the changes reflected in it. So you can pretty much travel between all of these different commits, but see what I have here? This is when you actually branch. So if you're just making comments, your comments are just going to look like this on a graph. But if you want to branch, so branching, what you can do is you can do git branch, and it's going to create a new branch with the current comment as its parent. I'm just going to call it branch 1 or something. And if I do git log, you can see I have head, master, and branch 1. So this branch 1 I've created a branch that basically points to the same comment, you could say. So essentially what we have right here now, we have something like this, but you also have a reference pointing to here. So you have branch 1 on top of this node essentially, but here's what I can go ahead and do. So I can actually, let's say I want to make a new change. So I'm going to go ahead and git checkout branch 1. I'm going to switch to that branch. So what I'm doing here, I'm going into this branch. So you're going to notice it still points to the same comment right here. But what I can do is I can make a change to this file. I can do something like echo third line and then append that to example.txt, git add example.txt, git comment add third line, git log, and I've actually made this change in branch 1. So branch 1 has actually gone ahead and gone off and become its own comment essentially. So branch 1 is actually over here now. Branch 1 has a separate feature from the other development branches. So you can probably guess how this would be really important for when you're programming, because you can work on features in parallel. So this is actually one of the features that really separates Git from other version control systems, because you have this branching capability. And there's a lot you can do with it, really. But I just want to show you guys that you can branch. And I don't think I elaborated, but you do git checkout and then a branch name or a comment name, and it actually puts your head pointer on that. So you basically focus on that branch. You can start working with that branch. So I can actually go ahead to like a previous comment. And now my head is going to point to the comment that we have that we had previously, this one. And I can always just git checkout branch 1 to go back to it. Now it says switch to branch 1. So another thing you can do with branches, you can actually go ahead and merge your changes. So if you do git merge, actually let me go ahead and check out C927. I can go ahead and git merge branch 1, and it's going to actually merge the changes from that branch. So like I added the third line, it's actually going to put that into my example.txt now. So it's going to say sample text, second line, third line. So you can actually have this branch still, but you can also just take all the features from here and just put it into this node. So that's basically branching in a nutshell. You have git branch, you can type just git branch to see all your branches. You can do git branch name, some like random name to create a new branch. You can do git checkout for some branch or some comment. And you can do git merge and then a branch name, and it's going to merge the changes in that branch into your current comment. So that's one of the features of Git, but the last feature of Git that I want to talk about is something called git remote. So what I'm going to do here is I'm going to type the command git clone. I'm going to go ahead and clone the sample directory into just another directory. I'm going to call it sample2. Cloning into sample2. So I've actually basically made a copy of that directory. You can go ahead and go to sample2. You can see ILS. You can read it. I have sample text, second line, third line. So it has the latest comment. So once I have this here, what I can do is I can be in sample here, and I can go ahead and do git remote add sample2, or I could just call it remote, actually remote 1, and I can give it a file path sample2. And what that does is you basically track this other repository. You track the sample2 and you give it a name remote 1. So like, let's say you have this folder right here. So this folder, what do we have it named as? We have it named as sample, right? So we have sample here, and then we have another folder, sample2, which is basically the same thing. But this doesn't know about this, but what you can do by doing git remote add, it actually knows about this now. So like, this has a reference to this repository over here. And this is where stuff like GitHub comes into play. I'm not going to really talk about GitHub in this lecture, But really GitHub just acts as a repository host. You host repositories with GitHub, and you kind of really just use it to collaborate with other people. So you can store Git repositories on GitHub, but you don't actually need GitHub for Git. But GitHub basically works off of this whole Git remote principle. It's aware of these other repositories, and that's really what remote is. Being aware of other repositories other than itself, like cloned repositories. So this can be practical if you're like a lead developer or something. So like let's say we have this computer here, a computer 1, and then you have 3 people working under you. So like you have one client here, you have one client here, one client here, and then you can have all of them as separate remotes. You can have remote 1, remote 2, and then remote 3. So here's the thing, all of them can actually go ahead and see this main. So like we'll just call it main. This is the main repository, and they can all track this, and you can actually exchange data between all of these different devices. So Git remote, when we have a remote and we want to push changes from this remote, like we make some changes to a file and we want to send it to this main server, this main repository, what we do is git push. So you're basically pushing changes to this main computer over here. And likewise, you can also go ahead and request changes from the computers themselves from the main one by doing git pull. You pull changes from another repository. Or actually, alternatively, even better, let's say the main one got updated. If the main repository got updated and you're a computer, you're a client, and you want to get these changes, you will actually do git pull, and then you'll retrieve the changes from there. So you basically have this connection, this back and forth connection between the two, and you can do git push to push changes to the repository and pull to pull changes from the repository. So like if I go into sample 2, and then if I want to make a change, I go last line, and then I append it to example.txt. So what I can do is do this git push command, and here's the syntax for it. So you can have this remote branch, or actually let me see, git remote. So by convention, origin is the reference you name your remote repository, like the main one, if you only have one of them. So origin is going to refer to the main repository. It's going to refer to sample right now. So I'm going to do git push, and the remote's name is going to be origin, and I'm going to give it a local branch name, and our local branch right now is just going to be sample 2, I believe, or no, it's master, and then the remote branch is going to be master. Master failed to push some refs. Okay. Something bugged out, but basically use git push, you give it this remote name, and then you'll give it a local branch and a remote branch. It's going to push those changes to it. So normally what would happen is I would have this last line and I'd push it to the main repository sample usually. And likewise, if something changed in the main repository, go to sample, and if I add the same change actually, last line, sample text, and a cd into sample 2, and if I do git pull, okay, so I think I might have missed a command or something there, but basically git pull would update the current branch based on information from a remote repository. So when you do git pull, what would happen here is, oh, actually I remember what I did. I didn't actually go ahead and add and comment the changes, yeah, but if I did, basically it would take those changes from that repository and it would pull it into this repository, and then this would have the changes to reflect that main repository. So that's really the function of remotes. Unfortunately I didn't comment and add there. I could go ahead and do it right now actually. Git status, you can see, yeah, modified example.txt, but nothing's been changed. Go ahead, git commit, add final change. I hope I haven't even added it. Okay, git commit, add final change. Now I can go ahead and push this change. Okay, yeah, I missed something, but in a nutshell, that's really what it is. I'm pretty sure I missed a command or something along those lines, but you comment those changes, and then you can move files from between these two repositories. So that's really the whole topic behind Git remotes. So for Git, we have a few essential topics. We have commits, and commits are really just snapshots of files and folders, right? So snapshots. And we have the concept of branches. And branches are just going to be like, just think of it as parallel development. And then you have remotes, and then you can think of that as tracking clones. So you track another similar repository and you can exchange information between them. So this is what really sets Git apart from other version control systems. But there's another feature that you should realize about Git. Traditionally, with a lot of other version control systems, what they don't have is they don't have the ability to operate locally. So if you've noticed, I've done everything here from the command line, but other version control systems, they usually depend on some kind of server, but Git doesn't. All you need is a command line. You do everything locally, so you can utilize all of Git's features when you're not on a network, and then when you are, you can just go ahead and upload all of your changes by using Git remote. And that's one of the most powerful features of Git. You don't have to be restricted by some sort of server. You don't have to require a server to make any of these changes. You can do all of your changes locally and then just go ahead and upload them to the server when you're ready. And then just to kind of wrap things up, I will go over a few other commands I might have forgot to mention. So if you've made a change, you can actually do git diff, and git diff will show you the changes that you made. You can see plus final change. It means I've added final change as a line. If you do git diff, it'll show you that. And git log, of course, probably the most important command honestly in Git. You're going to be doing this all the time just to see what your thing looks like. And actually, going back to one of the activities, there's two exercises that I figured would be really useful to go over. So number 2, what do we have here? Clone the repository for the graph class website. So to do that, go ahead to GitHub, and I said I wouldn't go over GitHub, and I'm really not, but I'm going to go ahead and show you how you would clone something from GitHub. So you'd go here, code, you take this, you copy it, open up your command line, you do git clone, and then go ahead and put in that URL. And you're going to start and go ahead and download everything to your local computer. I already have it though, so I'm going to go ahead and close out of that. I have missing semesters, see the missing semester. So what's the exercise? Store the version history by visualizing it as a graph. What was the comment message associated with the last modification to the collections? Okay, so to see who commented, we will do git log readme.md, and we can see that the person who made the latest comment is Anish over here, author. It shows you that, and it gives you their email too. And if you do git blame.config.yml, it'll show you basically the name of who made these changes to a file in specific. So it's really important if you're actually collaborating with other people. And if I want more detail about one of these comments, I can do git show, and it's going to give me a more detailed recollection as well as the specificities about that change. So the last person to modify readme.md, Anish, and then the comment message associated with the last modification to collections. That's going to be this one right here. It's number 2. And like many command line tools, Git provides a configuration file called tilde.gitconfig. So this is in your root directory if you're running Linux. It says create an alias in git config so that when you run git graph, you get the output of git log. And then these are just a bunch of options. And this is something that lets you visualize your logs in Git better. So I'll actually go ahead and tell you how to get to your git config. Go ahead to your root directory and then open up .gitconfig in a text editor. So I already have it here, but so for this exercise, what you're going to do is go ahead and just append this alias graph equals log all graph that create one line. So if you want to make your own shortcuts on Git, this is how you do it. You go ahead to this config file, and then you can go ahead and change it. So this Git graph, it's going to give me all these options, and let me demonstrate what that would look like. So the Git graph, it'll show you like this kind of visual representation of what everything looks like. Like these branches look a little bit strange, but the colors and branches actually do mean something. They symbolize when some branches might refer to the same thing and whatnot. I'm not too familiar with it, but you can actually customize this a lot whenever you do git log. So definitely look into that if you want to actually really get into Git, because you want to make sure that you can visualize your data very well. But with that, I believe I've covered everything I wanted to cover about Git. And I want to tell you guys, Git is something you do have to practice. I do encourage you guys to go ahead and actually use it. It's harder to see how useful it is off of just a lecture, but Git is really invaluable because as programmers, just think of it like this. If you're ever working on a project and then you make some change, have you ever had that moment where you didn't want to make that change? Like you wanted to go back in time, go ahead and revert that, or you've had some bug, or you just want to work on like another feature without having to worry about messing up your project? That's what Git is for. And on top of that, you also have GitHub. Employers enjoy GitHub, so like if you ever do or work on a project, go ahead and GitHub and then put your project there. Go ahead and use it as version control, but on top of that, you can also just use it to show off to potential employers. So that's the purpose of GitHub there. But just in general, Git is really useful just for tracking version history and just working on any project in general. It doesn't even have to be programming. A lot of people actually use this for like graphic design and stuff. It's just very useful and one of the best things that have come out of programming in recent decades, I'd say. Probably the most important topic we've gone over in this club so far.